Hello, everybody. Welcome to Andrew Academy. Today we're going to be learning about math. Today we're going to be solving the infamous Dreamherd equation. This is an equation that has not actually been solved before, so we're going to be solving it for the first time here. It's actually an equation with a lot of backstory to it and a lot of history. So it started when a shepherd had a dream about this equation, and so it's just kind of started out as the dream by a shepherd, so Dreamherd, But so yeah, that's kind of how this started, and mathematicians have been stumped. Many have actually said it's impossible to solve. It's not solvable. And so we'll get into that and the reasons why they think that. But I actually will be solving it this time, and I'll be showing you how that's possible today. So it goes as this: a to the power of 5 minus y squared equals be over 5 divided by x to the power of 5 equals be over 425. So this is the Dreamherd equation. And so you're already probably seeing a few of the reasons why many people have thought it was impossible, and that's because there's an equal sign in both the numerator and the denominator. What do you do with that? It's not solvable, right? Well, no, I'll actually be showing you how to do it step by step. So the first thing to do in solving this equation is, well, as you know, BE equals 42.6. So this is the first thing that we need to realize, the truth that BE, as we all know, equals 42.6. And so this is going to be really helpful right off the bat in plugging in 42.6 for BE. So I'm just going to go erase the BE's real quick, and we're going to be replacing them with 42.6. It's just something we all know, so don't worry too much. So 42.6, 42.6. Right off the bat, we can use our calculator to solve the top of 42.6 divided by 5, and that will be 8.52. So we can once again get an eraser. We're just going to go plug in, or we're just going to go solve for that, which is, if you just go check on your calculator, or you could do it on hand. You can do whatever you want, really. But we're just gonna go down here. 8.52. There we go. Now for the bottom one, it's actually 42.6 divided by 425 is actually a really big number. So to solve this, we're actually gonna multiply both sides by 425. And since there's an equal sign on the bottom, this actually doesn't change anything on the top. So what we get is 425 x to the power of 5 equals 42.6. And so this is going to be our denominator. And so what I'm actually going to do right now is we're just going to erase the whole top part just real quick. And we'll just rewrite it with the new denominator. So we'll just do that real quick. Let me just get that going. So we got a to the power of 5 minus y squared equals 8.52 divided by 425 x to the power of 5 equals 42.6. So this is where we are so far. Now, for this next thing that I'm suggesting as a postulate is when there's two equal signs on the numerator and the denominator, we can actually just have it all equal 0 so that we can actually solve for it. So we're adding a third one there. The next thing that I suggest is we can actually cross-cancel these equal signs. As you all know, this is a move that we can do in math. So what we're going to do is we're actually going to cross-cancel both of these equal signs. So let's just erase those and just add a plus in there. There we go. So it actually becomes a to the power 5 minus y squared plus 8.52 divided by 425x to the power 5 plus 42.6 equals 0. So this is a huge leap in trying to solve this Dreamherd equation. So next up, what we're going to do is we're going to multiply both sides of the equal sign by the denominator. So we're going to multiply this side by 425 x to the power 5 plus 42.6. So multiplying that by that side, it'll just give us the numerator. So we'll just get a to the power 5 minus y squared plus 8.52 equals 0 times 425 x to the power 5 plus 42.6. And so now we can use the distributive property to multiply 0 and 425 x to the power 5, which will just give us 0, as well as that 0 times 42.6, which will also give us 0. So what this is actually going to give us is just a to the power of 5 minus y squared plus 8.52 equals 0. So we're actually just going to get 0 at the end of this. So let me just write 0 right there. So now, as you can see, this is a huge leap. We're getting really close. So let me just go erase this up here. Hope you're following along at home. If not, do. And so let's just rewrite our equation up here. A to the power 5 minus y squared plus 8.52 equals 0. And so I'm sure a lot of you now know what we're supposed to do next, which we're going to subtract a to the power 5 from both sides. So we're going to subtract a to the power 5 on both sides of the equal sign. So we're just going to do that. And what we're going to get is negative a to the power 5 equals negative y squared plus 8.52. So next up, since we want to just kind of make this normal, we're going to subtract both sides by negative 1. It gives us a to the power 5 equals, and this is going to make this positive y squared minus 8.52. So here we go. We've narrowed it down a bunch now, so let's just do this real quick. Hold on. Give me a sec. And here we go. Okay, so we're just going to go erase this top part right here. And so now what we can do is we can take the fifth root of both sides of the equal sign. So we're going to take the fifth root, and as you know, the fifth root of a to the power 5 is a. So what we get is a equals the fifth root of y squared minus 8.52. And that's the answer. As you know, A stands for the answer. A equals answer. So this is the answer. A equals the fifth root of y squared minus 8.52. And that is how you solve the Dreamherd equation. Thank you everybody for watching the Andrew Academy channel. Be sure to hit that like button, hit that subscribe button, and hit that comment button telling us what you think below. Really looking forward to what your thoughts on are the first time ever solving the Dreamherd equation. I'm still pending the submission for the postulates to be approved, but I'm sure it'll be approved, so I know we got this. Yeah, just thanks for watching, and goodbye.